Hi, my name is Alex, and in this episode, we'll review how to track experiment progress while running your RL policy training in the cloud on NVIDIA GPU using RSLRL in our case. And for tracking experiment progress, we're going to use weights and biases. So there are several great tutorials on the weights and biases documentation. As you can see, we're going to use our workspace in weights and biases, and we're going to see the results, the tracking experimentation results landing under a certain run in weights and biases dashboard. And also currently we're running our RL policy training for shadow hand, dexterous shadow hand for cube repositioning task, headless in the cloud. So let's see how this looks like, and let's initiate a synchronization of the tracking results from our compute in the cloud running on GPU into weights and biases workspace. So we're looking at the cloud machine that runs RL training right now, and we just got into its terminal, and also did a very quick, just like in the previous video where we did the registration of the model into weights and biases. We did the quick installation of the virtual environment here for convenience, and then also installed our weights and biases library through pip install. So quick recap of how virtual environment was established. So we basically executed this through apt-get install command, and then after this you basically do, so I'm not going to do this because I already have it, and then you do python 3 mvenv, and then we created our virtual environment. As you can see this already on the left. And then once you created that virtual environment, then you just simply source, and then activate. So this is gonna activate our virtual environment, and there's no harm doing this. And then after this, let's see what's being tracked and what's being logged as a part of our policy training. So I'm gonna review what's inside of this IsaacLab folder in the workspace, and we have our logs folder. So what we want to do, we want to go into our logs folder and see what's inside. So I'm just gonna take a shortcut here very quickly. So cd into that folder, and then you see that we about halfway through the training. So we iteration 5,000 on the scale of 10,000 iterations for the training. And then we have this events out tf events file. And if we want to see just the size of it as the training goes on, let's take a look very quickly. So I'm going to use the ls-lh command here. And it looks like currently it's about 3.7 megabytes right here. So there's definitely some stuff in there. And let's just get back to our original directory. And we're going to use weights and biases Python code to basically synchronize and get all the tracking and metrics from this machine, from a local folder, into weights and biases dashboard. So let's do that. So we know what the file is. We know that there's information being logged in there. So let's just go into Python session, and I'm gonna do import weights and biases. I'm gonna do from weights and biases import API. Then I'm gonna do weights and biases login, and I've done this before, so it remembers me. Perfect. Then I'm gonna do an object of API, and then the main command is basically it's called API.sync_TensorBoard, and this is where you specify 3 main parameters. So I'm gonna shortcut here, and then as you can see that there's a root directory with the timestamp as well as the full path to workspace IsaacLab logs RSLRL shadow hand, and then the project that we have in weights and biases portal established called shadow_hand, and then the entity, which is my organization configured in weights and biases portal. Once this is done, it's going to start the synchronization process. It finds one TF event file, and it's syncing right now from local into the cloud, into the weights and biases portal. So it's going to take some time here for the information sync. Yeah, it looks like the process have been completed, and we can basically we can exit from the Python session and switch over to the weights and biases workspace. Then we have a new experiment and a new run registered. Let's take a look what's in there. And as you can see, there's obviously we're going towards right now we're halfway through 5K steps for dexterous shadow hand RL training using RSLRL. And then we have all of the metrics that we are interested in terms of like the mean reward and mean episode, standard noise, and then also like we can switch. So this is 1 through 6 out of 14. Then we can see all of the different graphs describing and helping us understand the process and helping us understand the success of the training process. So this is how you can synchronize the metrics from RL policy training from the cloud machine running RL policy training in the cloud on NVIDIA GPU into weights and biases dashboard. Thank you.